Hi everyone, my name is Fatin Nukamarina binti Zulkifli and this is my group of member. And we are from Unimap. So today we wanna present about stress corrosion. But before we go, do you know about corrosion? Let me explain about it.
Okay, corrosion is destruction or deterioration of material by its environment and occurs due to chemical electrochemical action. It is a reverse process of extraction. In extraction, metal is extracted from ore, mostly oxide. For example, is iron oxide. In corrosion, iron is converted to oxide. Corrosion have 10 types, which is pitting, galvanic or two metal, uniform or general attack, crevice, intergranular, cavitation, fretting, selective leaching or dealloying, erosion, and stress. Now we move to the main topic. What means stress corrosion? Here are the examples of stress corrosion.
Hello you all, myself Sharvin. Let's see what is stress corrosion cracking. Stress corrosion cracking is known as SCC. Here we go. Stress corrosion cracking is a growth of crack formation in a corrosive environment. Stress corrosion cracking is highly chemical specific in certain alloys are likely to undergo. Stress corrosion cracking react when exposed to a small number of chemical environments. This made stress corrosion cracking is a progressive fracturing that occur in metals as a result of the combined influence of tensile stress and a corrosive environment. And this is element of stress corrosion cracking: environment, material, and stress. Let's see in environment, we have aqueous corrosion, high temperature oxidation, which goes to material was fractite fagio. Which go to stress, we can see stress-induced absorption, surface energy effects, addition, where nanomechanics. These are the three elements for making stress corrosion cracking.
Stress corrosion happen due to three factors. The first one is tensile stress. The second one is localized zone that are mean chemical active. And then the last one is formation of crack and propagation. Stress corrosion occurs due to the tensile stress, applied stress and residual stress on the susceptible material in the presence of a specific corrosive environment, resulting in the formation of crack which propagates. Stress corrosion cracking is failure mechanism that is caused by environment, susceptible material, and tensile stress. Temperature is a significant environmental factor affecting cracking. There are three common stress corrosion cracking that can related in our daily life. The first one is failure of metal resulting from joint action of stress and chemical attack. The second one is initiation and propagation of crack without any outside evidence of corrosion. The last one is sudden and unpredictable failure, such as catastrophic on a ship.
Causes of SCC. There are three main causes of SCC has given follow. First, a accessible material. Stress corrosion cracking can be caused by the type of material being used. This is because different materials are more or less susceptible to stress corrosion cracking than others. For material selection can lead to stress corrosion cracking due to the material being susceptible to SCC in the corrosion environment that it is operating in. Second, corrosion environment. The service environment that the material is operating within can contain chemical species which causes stress corrosion cracking to occur in different material. As a rule, material and environment selection should be considered together to avoid stress corrosion cracking. Third, tensile stress above threshold. This involves a material experiencing stress or strain from either residual stress or the direct application of stress or pressure. In the case of stress corrosion cracking, crack propagation is caused by mostly static stress. In order for the crack to be regarded as a stress corrosion crack, there need to be the pressure of factor related to material and environment too. How to identify SCC? Visual identification prior to failure is difficult due to the typical thickness of the stress corrosion crack. A low power hand lens will greatly aid determination. Detection of crack can also be achieved with ultrasonic radiography or acoustic emission technique.
Stress corrosion cracking is a delay failure process. That is, cracks initiate and propagate at a slow rate until the stresses in the remaining ligament of metal exceed the fracture strength. The sequence of events involved in the SCC process is usually divided into three stages. The first one is crack initiation, crack propagation, and brittle fracture. So you can see the graph below. The graph is crack velocity of stage 1, stage 2, stage 3, and stage 4 is a final failure. Mechanism of stress corrosion cracking. The first one is adsorption model. Specific chemical species adsorb on the crack surface and lowers the fracture stress. The next one is film rupture and pre-existing active part model. And the last one is embrittlement model. It's like hydrogen embrittlement. Hydrogen, this is a special case because hydrogen is a small molecule, as we all know. So it dissolves almost in all metal, and most of all it can easily diffuse between the metal atom in the crystal lattice. Mechanism of stress corrosion cracking. They are pre-existing active part mechanism. Active part is a material failure due to stress corrosion cracking that is characterized by the progression of corrosion along an intermolecular path of least resistance with high concentration of tensile strength. So you can see the grain boundary and strain generate. For grain boundary precipitation, consequently, a form of corrosive corrosion can occur whereby the grain boundary corrodes with the specimen surface and the crack walls remaining passive. This process can occur in the absence of stress, giving rise to intergranular corrosion that is uniformly distributed over the specimen. The effect of the applied stress is probably mainly to open up the cracks, thereby allowing easy diffusion of corrosion products away from the crack tip and allowing the crack tip to corrode faster. Strain generate active part mechanism. Strain is like controlling influence, and strain generate. Initially, a passivating film is formed on the metal surface. film is ruptured by plastic strand and exposing bar metal. This film will form again and continue the process and make a crack propagates by successive dissolution of crack tip in the process. Emergence of slips step also considered to cause film rupture.
I am the last presenter of this presentation. First of all, prevention of stress corrosion cracking. Introduce compressive stress by short pinning, for example. Use of materials known not to crack in the specified environment. Avoid the chemical special species that causes SCC. Next, control operating temperature and the electrochemical potential of the alloy. Control of hardness and stress level, residual or load. Next, material. One of the main prevention methods involves using a non-susceptible material. This is an important way of controlling SCC as it prevents this form of corrosion from occurring in the service environment that the material is operating in. However, this prevention method is not always an option, and so it may be more applicable to control the service environment that the material is required to operate in. Besides, environment is the major effect also. Another preventive method involves the mitigation of the service environment by removing, limiting or replacing the relevant corrosive chemical species. This prevents stress corrosion cracking from the occurring. However, this can be very difficult factor to control if corrosive species are naturally present in the environment where the material is located. For example, authentic stainless steel is seawater. Other methods of prevention include controlling the temperature to ensure that it does not exceed a certain temperature, including fluctuations. Moreover, stress and strain. Removing or reducing the tensile stress placed on a component is another way of preventing the occurrence of stress corrosion cracking. One of the main downsides of the preventive method is that it can be difficult to control the stress that a material experiences at regions where stress can concentrate during fabrication or operation. Here are some prevention methods. Choosing a material that is not susceptible to SCC is the service environment. Residual stresses can be relieved by stress relief annealing. Similarly, short pinning or give blasting tend to introduce a surface compressive stress. Neutralizing the environment whenever possible, example, reducing chloride ion concentration. The preventive measures are, there are a number of different ways to control SCC. The method used depends on the applicable and may involve changing the mechanical, metallurgical and environmental conditions. Mechanical. Avoid stress concentrators, relieve fabrication stresses, introduce surface compressive stresses, reduce operating stresses. The second factor is metallurgical. Change alloy composition, change alloy structure, use metallic conversion coating. The last factor is environmental. Add inhibitor, modify temperature. The conclusion of SCC is many materials, particularly high-strength materials, are susceptible to stress corrosion cracking when exposed to a specific environment. For example, cold work brass, which is found in ammunition cartridge, is susceptible to stress corrosion cracking when exposed to an environment containing ammonia. In chloride-containing environments, titanium alloys, aluminum alloys, and high-strength stainless steel are susceptible, and specified alloys which are resistant to stress corrosion cracking should be used. The stresses required to initiate and propagate cracking are often low, and many failures occur due to residential stresses rather than applied stress.